All right, now that we've done some examples of the valence shell expansion, let's do some more. Let's draw the Lewis dot diagram for XeO2F2, and we'll spot you the central atom as being xenon. So here is our skeletal structure. Xenon in the middle, oxygen, oxygen, fluorine, and fluorine. Oxygen has 8, xenon has 8, oxygen has 6, fluorine has 7. That gives us a total of 34 electrons. Let's put single bonds around. We have a single bond between oxygen and xenon and the fluorines. That only used a total of 8 electrons. We started with 34. We have 26 left. We have 13 lone pairs. 13 lone pairs, let's put them around. We can put them around fluorine and oxygen. That looks good. This accounts for 12 because we've got 3 on each of the fluorines and 3 on the oxygens. So where do we put the last lone pair? We can put it on xenon, and that'll expand its octet. So let's put it on xenon. There we go. We've expanded the octet. Yes, we've used up 12 lone pairs, all 24, by putting a lone pair on xenon. There we go. Now, let's take a look at the formal charges. When we look at our formal charges, the formal charge on xenon, 8 minus 2 minus a half of 8 is plus 2. Formal charge on oxygen, 6 valence electrons minus 6 electrons on lone pair, minus a half of 2 is minus 1. Formal charge on fluorine, we have group 7 minus 6 electrons in lone pairing, minus a half of 2, that equals 0. Okay, so that leads us with 3 atoms that have non-zero formal charges. Let's see if we can reduce the formal charge on oxygen. We can reduce the formal charge on oxygen to 0 by taking that single bond and making it a double bond. When we do that, we now have a formal charge on each of the oxygens, and we also have a formal charge on xenon. So that gives us the best Lewis structure.